Myself, Dr. G. Sumati, Associate Professor from the Department of AI&DS, Konganadu College of Engineering and Technology. Today I am going to discuss about operating systems, introduction and operating system structures. First, we will see about what do you mean by operating system. Operating system is a application program that act as an interface between user and the computer hardware and controls the execution of application programs. Then we will see about software types. There are two types of software types, application software and system software. Application software nothing but it is an user program that is performing a specific task for the user. For example, WhatsApp and MS Office. And system software is a overall resources, hardware resources are managed and to create an program development environment and create a runtime environment. For example, compiler, assembler, debugger, loader, and libraries and OS. These are coming under system software. Next, we will see about mainframe systems. First, high performance computer and used to handle many commercial scientific applications and large organizations for critical applications like bulk data processing for the complex task. Then we will see about a desktop system, that is the separate components are assembled together. For example, mouse, keyboard, monitor, these are assembled together to perform a specific task. For example, Windows 98, Windows 2000 and Linux operating system. Then distributed systems. Distributed system is a different network computers and coordinate their actions by passing messages to one another, and the processor do not have shared memory or a clock, and each processes have own local memory. This is the block diagram of distributed systems. Computer 1, 2, 3, 4, and distributed system layer is the middleware. Then each processor has its own memory, local OS1, OS2, OS3, OS4, and application software running between computer and OS. There are two types of systems, client server systems and peer-to-peer system. In client server systems, the client requests a services from the server, and the server provides the particular resources to the server. And peer-to-peer systems, number of equal participants in the data sharing. Then we will see about clustered systems. Clustered system nothing but grouping of the system to work similarly to parallel operating systems as they have many CPUs, and two or more individual systems connected with each other, and independent computer system along with the shared storage medium, and all systems perform all tasks together. This is the block diagram of clustered systems. Each and every computers are node connected each other, and all the computers or nodes are the required details extracted from the storage area, that is main server. There are then types of clustered system: asymmetric clustering system and symmetric clustering system and parallel clustering system. In asymmetric clustering system, hot standby mode, that is monitors all the functions. In symmetric clustering system, monitors all nodes at the same time. Parallel clustering system allows to multiple users to access similar data on the common shared storage system. Then real-time systems, it is the time requirements system, that is meet strict time requirements, and multiple programs are being executed at the same time on a single processing core, and scientific experiments, medical imaging systems, and some display systems are real-time systems example. There are two types of hard real-time systems, hard real-time systems and soft real-time systems. In the hard real-time systems, the critical task has been completed on time. Soft real-time systems, it gets priority over other tasks. And handheld systems, it is a portable devices, that is personal digital assistants and cellular telephones with the connectivity to a network such as the internet. It is the small size and used for compact. Handheld devices may use wireless technology such as Bluetooth, allowing remote access to email and web browsing. Next, we will see about basic elements of a computer system. There are four main features available in basic elements of computer system: processor, main memory, I/O module, and system bus. Processor is a central processing unit, and this is the heart of the computer system. It controls the operation of the computer and performs its data processing functions. And the main memory stores the data and programs. I/O module move data between computer and its external environment. A system bus is the communication channel. It provides the communication among processors, main memory, and I/O modules. Next, we will see about instruction execution. Instruction execution done by two steps. First one is fetches, second one is executes. Fetches the instruction from the memory and perform the operations in the central processing unit. Then in the second step, the processor execute the each and every instructions. The data are retrieved from the main memory. So instruction execution takes place in CPU registers only. This is the instruction execution full cycle. First fetch instruction from the memory, then decode the instruction. That is identify the operand and operators in the instruction. Then fetch the operands from the memory. Then execute the instruction in the processor services. Then system calls, it is an interface between running program and an operating system. A system call is an explicit request to kernel mode via software interrupt. A system call like procedure call, but system call enters kernel. All system call return an integer value. In the kernel, positive or 0. It is denoted the termination is successfully completed, and negative in the sense the error condition will occur. Three general methods are used to pass parameters to the operating system. First one is register, second one is stack, and the third one is address of the block. This is the examples of Windows and Unix system calls. The process control in the Windows operating system, the command used by create process. In Linux or Unix, fork command, and file manipulation operation done in Windows using the command create file. In Unix, open file. Next, we will see about system programs. System OS is a collection of system programs. It provides the application program environment on hardware for program development and execution. Next, we will see about operating system structure. The various structure is the most important four structures. Simple structure MS-DOS, more complex Unix, layered and abstraction structure, and microkernel MAC structure. First, we will see about simple structure MS-DOS. In this operating system, application program directly interact with the ROM BIOS device drivers. In between these two programs, resident system program and MS device drivers are available. Non-simple structure Unix. Unix limited by hardware functionality, and in the Unix operating system, the kernel is most important factor. It provides system calls for the file system, CPU scheduling, memory management. Traditional Unix operating system structure, the kernel is a portion of the operating system and gives the services to the hardware, signals, terminal handling, character, IO system, terminal drivers, file system swapping, block IO system, disk and tape drivers, CPU scheduling, page replacement, demand paging, virtual memory. Then in the layered approach, the first highest layer is layer N. This operating system is divided into number of layers. The bottom layer, layer 0, is the hardware. It represents the all hardware management, and layer 1 is the application programs are done in this part, and each layer consists of data structure and a set of routines. Next we will see about kernel. It is the portion of the operating system and it is the software code that resides in the central core of operating system, and it has cell is outer part of the OS, and it interacts with user commands. And then kernel works in kernel space, user performs in user space. Kernel code is in protected area in memory, and kernel does not directly interact with user, it interacts with cell. Then kernel is the first part of the OS loaded into memory and remains entire computer session. Thank you.